Hi guys, every time I record a video like this, I have to stop myself from being that embarrassing teacher and making jokes about, hi, welcome to my guide, hi, subscribe, like, and comment. Anyways, so this is on lesson 7.5 exponential functions. So exponential functions, again, apply to the real world. This is things like, if you put some money in your savings, if you are trying to figure out how much your car is worth 10 years down the road. So if I want to figure out how much I can sell my car for in 20 years, this is the kind of thing I'll be looking at. This is also, if you have some food in your fridge and you have left it for too long and it gets moldy, exponential functions actually represent the growth of the mold on your fridge food, your fridge mold. It also can represent bacteria, things like COVID-19 and different viruses that spread could be exponential functions as well. They're represented in this way. So get out your study guide and intervention worksheet, and we're going to do a couple problems from there. So number 1, we are going to make a table every time we do one of these. So we're going to have an x, and then we are going to have our function 0.3 to the power x, and then that is an ugly x, and then we have our y. So my favorite numbers to check out are -1, 0, 1, and 2. Just to check out what's kind of happening in each of these spots. So on your calculator, if you have a calculator, if you have your phone on your phone calculator app, if you have an iPhone, if you rotate it, I wonder if this has it on here. You can put in whatever exponent you want. So if you type in your regular calculator, if you have a calculator like this or like this, you are going to type in the number 0.3. I'm going to try to do it on all of them just to show you. You'll type in 0.3. Then you're going to type, if you have a calculator, you are going to press the caret button. The caret button looks like this. That's going to say to the power. So you'll press that right there. If you have your calculator, so I put in 0.3 on my phone calculator, on there is a x to the power y right here. Sometimes it will have the little caret symbol, sometimes it's x to the power y, sometimes it might be something else, but you're going to say x to the power y, and then you're going to type in your value. So the first one I'm going to have is -1. So I'm going to type in parentheses, -1, close parentheses, and say what that equals. If it's in my calculator, you'll do -1 as well. You might need to put it in parentheses. And I got 3.33333. In this calculator, I typed it in. It did not need parentheses, and I press enter, and it gives me 3.33333. Try it on whatever calculator. You could use one online. It should be fine either way. It's not cheating to use a calculator to calculate these values. I do not expect you to have them right away. So you'll have 3.3333 or 3 1/3. 0.333 repeating is 1/3. Either way. Then you're going to check out 0.03 to the power 0. Anything to the power 0 is 1. So we know that this is going to be 1. That's why I like the 0.0. Then we'll say 0.3 to the power 1, which is just 0.3. Then we'll have 0.3 to the power 2. In your calculators, this is going to be the squared button, or you could do the caret and 2 as well. Either way. And that is 0.09. So real small number. That's what it should look like. And then we can graph it. So at -1, our number is 3 1/3. So 1, 2, 3 1/3. At 0, I'm at 1. At 1, I'm at 0.3, so that's like close to a third. At 2, I am 0.09. So you're getting closer and closer and closer to 0. This is called an asymptote. I'm not swearing. It's an asymptote. Don't say the other word. It's an asymptote, or asymptotic behavior is not being an asymptote. It is when you get really, 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 really close to a number, but you never actually touch it. That happens a lot with, if you're talking about radiation decreases over time, but it's still kind of barely there, even after years and years and years. There's still a little bit of evidence of it. So with exponential functions, there's this huge growth that happens really fast, or there's this huge decrease that happens really fast and then it slows down. So if you look at this, it's going to have this huge decrease and then it's going to get closer and closer and closer and closer to 0, but it's never going to quite touch. So your asymptote is at y equals 0. That's where it's never going to touch. You're going to learn a lot more about asymptotes in Algebra 2. It is very interesting, and you get into it in calculus and logarithm functions, which hopefully we'll eventually get to in my class as well. So pause this if you need to. I'm going to move on to the next problem. Number 3. So you're going to try number 2 on your own. I figured I'd do 3 because it's just a little bit more challenging. You're going to do the same process of x. Then you have your 1/3 x plus 1. And then your y value. And here's your table. So again, you could try -1. Since it's plus 2, I actually might try -2, but -1 will work. You don't have to pick those numbers, but they're usually the easiest for me. 0, 1, 2. We'll check out what that's doing. So we have 1/3 to the power x. You notice how it's in parentheses, and that's because in your calculator, you're going to have to type it in parentheses. That's in your phone calculator, in whatever calculator you're using, you're going to put it in parentheses. So if I were using my regular calculator here at school, I'd have 1 divided by 3 in parentheses. Then I want to do whatever power I picked. In the case of the first one, I picked -1. So I'm going to do a little caret, or, that x to the power y in your phone calculator sometimes. You do a calculator online, and then you're going to do -1. So 1 divided by 3 to the power -1. I think it's backwards for you, but you get the idea. This is 3. Now there's still this +1, so whatever that is, +1. 3 plus 1 is 4. I'm going to write whatever I used in my calculator +1, just so I remember. Anything to the power 0 is 1. So you have 1/3 to the power 0, which is 1, plus 1, which is 2. Then you have 1/3 to the power 1. Anything to the power 1 is just itself. So you have 1/3 plus 1, which is 1 1/3. Pretty straightforward. 1/3 to the power 2 you could do in your calculator, but it is just 1/9 plus 1. So 1 1/9. So we're getting kind of closer and closer and closer. So it'll be interesting to see. This +1 does something interesting. Look for it as we graph this. So x is at -1, it's at 4. So 1, 2, 3, 4, put a point there. At 0, it's 2. So 0 left or right, 2 up. Oh, I didn't scale it. They're counting by 2s here, so I need to fix that. -1, so they're counting by 1s this way. It is 4, so 2, 4. At 0, it's 2. At 1, it's 1 1/3, so it's going to be over here. Then it's at 1 1/9, so it's Maybe I should do this a little bit more accurate. A little bit here, and then it's getting closer and closer to 1. So if we were to graph this out, it's going to be this huge decrease first, and then it gets closer and closer to 1 instead of 0. So this +1 actually shifted the entire graph up 1. That's what that +1 means. And so that's how you do those. Pause this, try problem number 2, and then we'll keep going. So then it says determine whether the data set displays exponential behavior. Yeah, right, yes or no, and explain. So these ones are kind of nice. You guys will like these because they're pretty straightforward. You're going to check out what the rate of change is. If the rate of the change is the same, it's just a linear equation. If it's getting big really fast or getting small really fast, it's an exponential function. So here you're growing by 1, that's fine. Here you're adding 5 each time. So you would say no. Linear. The rate is 5/1. I'm going to let you write that down. I'm not writing it because writing with my mouse is not easy. Here we're adding 1. That's fine. But when you check it out here, you go from 3 to 9, 9 to 27, 27 to 81. So it's getting big super fast. So you would say yes. And this is actually, to the power, 3 squared is 9. 3 to the power 3 is 27. So this would be a y equals 3 to the power x problem. You don't have to write that down, but that's just what I noticed from this. I'm going to show you just a couple more. Try 3 and 4 really quick, and then I'm going to go to 5 and 6, so pause me here. Then you're going to do 5 and 6. So again, this rate looks the same, 5 each time. Here you go minus 0.5, then you have minus 0.25, then you have minus something even smaller, so it's getting smaller and smaller and smaller. So that's not linear, we would say yes, exponential. Because 5 to 25 is 5 squared, is 25 to 125 squared again, 25 times 25. If we were to look at 6, that rate is the same, but 3 to 9, 3 squared is 9, 9 squared, or to the power 3 again, you get to, or times 3, sorry, misspeak there. Times 3 is 27, times 3 is 81, times 3 is 242, so we would say yes, times 3 each time. Three to the power x. I wrote another 3 instead of 3 to the power. Or sorry, 3 to the power negative x because it's a fraction, so it's going to send it down. Or 1 over 3 to the power x. And that's how you do the problems. Hope this goes okay for you. Try your practice worksheet. Hope to see you guys soon. Thanks for watching. See you guys.